Okay, let's start the class. Right, so today we're going to study sequences, right? Sequences. So who typed it? Austin. Hi, hello. Austin, hello. All right, so sequences. Okay, so so we're going to study sequences. So let's begin with a foreign problem. Then I'm going to talk about what kind of sequences we're going to deal with. All right. So sometimes you will given a following problem, what is the next term in the sequence? Okay, so the sequence have a few terms given, 2, 5, 8, 11. Okay, so this is a typical problem. Well, when you give a sequence, okay, you should look at the possible pattern. So many students already give me the answer here. So you'll find out there's some things, some rule it follows. That means it is always increased by 3 each time. You add 3 to the previous term, you get the next term. So that's why the next term will be 11 plus 3, which is 14. Okay. A sequence with such property is called arithmetic sequence. Okay. So arithmetic sequence, if we have A1, A2, A3, and A4, each term you just add the same number. Okay, just add the same number to the previous term, you get the next term. So can we find a general formula for this? Okay, the general formula will be as follows. You see, A2 equals A1 plus A, right? A3 equals A2 plus A, but the A2 is already A1 plus A plus A, so it's going to be A1 plus 2A. Okay, then A4, when we do some problem, we look at a few terms first. Okay, A4 is going to be A3 plus A, so that means A3 is already A1 plus 2A. That's why 2A plus A is 3A. So you see that when the number increases, from 4 to 5, and you can see that A5 should be equal to A1 plus 4A. Okay, so the general term, okay, the nth term will be A1 plus, should be 1 less than that, is n minus 1 times A. So this is the general formula. Okay, so we go back to the problem. Okay, we go back to the problem 2, 5, 8, 11. Okay, so my question is, what is the 100th term, right? Now, if we can find the general formula, then it's easy to figure it out. First of all, each time you add 3, right? So the general form will be the first one plus n minus 1 times 3, right? 3 is it's an increment, right? Each time you add 3 to the previous term. So we already have a general formula. The first term is the 2. So then once you get a general formula, you can get a 100 equals 2 and 99 times 3. Okay. Then you do the multiplication. You will get 99 times 3, right? Plus 2, it's going to be 299. Okay, only when you get the formula, we call the nth term formula, then you can get any term. Okay, you can get any term. All right. Now, let's take a look at next problem. We are given, we will ask what is the next term. Okay, in the sequence. Okay, so here's the 3, 6, 12, 24, 48. Okay, so I guess you will get the answer quickly. Okay, what is next term? 56, yeah, 96, yeah. So in it, many of you gave me an answer already. So you notice that it's this time it's always multiplied by 2, multiplied by 2, multiplied by 2, right? So the next term will be 48 multiplied by 2 is going to be 96. Okay. Now, a sequence like that is called geometric sequence. Okay. Geometric sequence has a property. Each time to get next term, you just multiply the previous term by the same factor, same number. Okay. So you have a sequence of, right? Then you have to multiply by the same, let's use R here. Multiply by R, multiply by R. This is how do we get to the next term, okay? So let's find the general formula, okay? The general formula is that A2 is going to be A1 times R, right? And what is A3? A3 is A2 times R. But A2 is already A1R, so we have RR, so it's A1R squared. Okay, how about A4? A4 is A3 times R, but A3 is already A1R squared, so then times R is R cubed. So then you can figure out the general formula. If it's AN, it's still A1 times R, I think to the N minus 1. Okay, so this is the nth term. So once you get this, you probably can get the 100th term, but that would be huge, right? So what is 20th term? The 20th term, okay? Instead of 20th term instead of 100th term, right? 20th term. How do you find out? Because above formula tells you A20th is going to be A1 R to the 19, 20 minus 1, right? So our A1, we begin with 3. So that'll be 3. And every time we multiply by 2 is 2 to the 19th power. Okay? So that is a huge number, but and that's called geometric. So there are two basic type of series. One is called the asthmatic sequence, another one is geometric sequence. But we in most of the cases, we are not given such simple sequence. Okay, the pattern will be, it's not like such simple. It could be complicated. So we probably have to go through a couple steps in order to find out the pattern, hidden pattern. So here's a certain problem, right? For example, what is next term, okay, in the following sequence, 1, 5, 13, 29, 61. Okay, this is not an arithmetic sequence. It's not a geometric sequence. Clearly, it's not a geometric sequence because 5 over 1 is not going to be 13 over 5. Okay, it's not geometry. That's not arithmetic sequence. All right, but can we find it? I probably still can. Some of you already gave me the answer already. Okay, Nansen did it pretty fast. Okay. Okay. Oops. Let me turn on the phone. Okay, and so please try your best to figure out the next term. right? All right, so everybody got to 125. Great. So what I'm going to do, so it's obvious in the geometry series, okay? But geometry sequence. So let's try to look at the difference. Okay, I got a 4 and a 13 minus 5. I hope you get a constant, same number, but unfortunately it's not. So I get 8. Okay, then 29 minus 13, that's a 16. And 61 minus 29, that will be 32. Okay, however, you get, we call it secondary sequence from the differences. Okay, 4, 8, 16, 32. Okay, 4, 8, 16, 32. So you will get this sequence of numbers. Okay, yeah. Okay, so you will see that 4, 8, 16, 32 is just multiply by this is a 2 square, and here's 2 cube, and the 2 to the 4th power, and 2 to the 5th. Okay, so clearly the next number is going to be it's going to be 2 to the 6th, right? The difference, right? So the answer will be x is going to be 2 to the 6 plus 61, and then 32 times 2 and plus 61. Let's say 62, 64, 61. It's 125. That's how do we get. Okay. Now, the question is, are you able to get the formula for the nth term? Okay. What is the nth term? Okay. Now to do that, I needed to label it, right? So A1, right? It's 1, 5, 13, 29, 61, right? So this will be A1, A2, A3, A4, A5. Right? I want to get to the AN. Okay. How can I do that? Okay. So A2 minus A1 is going to be 2 square, right? A3 minus A2 is going to cube, right? That's the way to find out. A4 minus A3 is 2 to the 4th power. A5 minus A2, A4 is 2 to the 5th. So the general term will be AN minus 1, 2 to the nth power. But can I get AN from here? Can I get AN from here? The answer is yes. You just add them all together. Then you will see A2 cancel out, A3 cancel out, A4 cancel out, right? All is left is AN minus A1 on the left-hand side. The right-hand side, you get 2 square, 2 cube, 2 to the 4th power, all the way to the nth power. Okay. And now what is A1? A1 is A1 is 1, right? We already know that A1 is 1. So A1 is 1. So that's why AN is going to be 1 plus 2 square, 2 cube, 2 to the 4th power, A to the A. So this is the nth term. But can we combine this? The answer is yes, okay? We have the formula is a 1 plus R squared plus R cubed, and R to the power n is going to be R to the n plus 1 minus 1 over R minus 1. Or 1 minus R to the R, right? It's the same, just to switch both the numerator and denominator. So this is the important formula, okay? We use that over and over again. So what is missing here, I think we just missed 2, right? So missing the 2. So if we add a 2 here, then you can apply the formula. So my conclusion is AN is going to be 1 plus 2 to the power n, okay, minus 2, right? Because the 2 is not originally included. So the answer will be 2 to the n plus 1 and minus 2. Okay, and 2 minus 1 is 1. So okay, the answer will be 2 to the n plus 1 minus 3. Okay, so this is a formula. And then you have to double check, okay? You double check, let's say A1 is going to be 2 squared minus 3 equals 1. A2, A cubed minus 3, which is 8 minus 3 is 5. Yeah, the matches. Okay, so this is the general formula. Not too bad, right? Yes, you know. Right, we're trying to find the nth term each time. Right, so our next problem is what is the next term and what is the nth term? Okay, and what is the nth term? Okay, we are given the following sequence, and I want you to do that. Okay. Yeah, it's a similar idea. Okay, you probably use a similar formula. Okay, you should be able to figure it out. The next term may be easy to figure it out, and the general formula takes a little bit more time. Okay. Right. I'll give you, yeah, if you have an answer to the first question, just show to me, okay? Then you're trying to work out the next one as a nth term. Yeah, the nth term is, oh, good, 485, yes. 485 is correct, okay? And as those got this answer, trying to get to the general. Okay. What are you doing here? Okay. So let's figure out the next term first. Okay. So we take the difference. I got a 4, right? And 17 minus 4, I get 12, right? And 53 minus 17, I got 36, right? And then you get a geometric sequence. Okay, the geometry sequence, it's a multiple of 3. So here's 4 times 3, okay? And here's 4 times, it's 12 times 3, okay? So 12 times 3, then it says 4 times 3 squared. And the same here, and it's gonna be 36 times 3. 36 times 3 would be 4 times 3 cubed, okay? Yeah. So, then you then you get the next term, right? The next term is x minus 161 is 4 times 3 to the fourth power. Okay, 3 to the fourth power, and then you multiply this out. It's 161. 4 times 3 to the fourth power is 81, and you multiply this out, and everybody got 485. Okay. Now to get the general formula, here's the idea, right? I think A2 minus A1 is 4 times 3, right? A3 minus A2 is 4 times 3 squared. And then A4 minus A3 is 4 times 3 cubed. So in general, I think this will be 3 to the n minus 1, okay? Because those must match 3, 3. Okay, and n minus 1, right? Now, we play the same trick. You add it together. And all those terms cancel out. So what is left is an minus a1. And here you will get 4, 3, 3 squared, 3 cubed, and 3 to the n minus 1. All right. Okay. A1 is 1. We know that's 1 plus 4. Question is how can I add this number together? Right? This number, okay? I remember, okay? It's 1 is missing, right? So 1, if 1 plus, you see, if 1 plus, we know that if 1 plus 3 squared, 3 to the n minus 1, then that will be 3 to the n minus 1, 3 minus 1, okay? So this is a formula we have. So this part will be just equal to the term on the right-hand side, n minus 1, right? Because you have to move 1 to the right-hand side, right? So let's simplify it. Yeah. I think this will be 3 to the n minus 3. Right. And then cancelled. Okay. Is that correct? Yeah. Yeah, I have to double check, okay? I'm going to go double check, okay? I hope I did not make any mistakes. I think I made small mistakes here. Let's double check. Yeah, I'm missing the, sorry. This is a, you know, yeah, 5 minus 1 is the first term, okay? This should be 0 here. It's not, okay? It's 1, it's 2, okay? Yeah. It's just 4, the first one. I forgot to here. Okay, it's here. So this will be n minus 2. Okay, and then this will be n minus 2. Okay, so when I add them together, here's n minus 2. And then that will be n minus 1. Okay, yeah. Okay, this is formula we have here. So it's n minus 1 and minus 3. And I think I have the first term here. When I add together, the first term is 1. So it's 1 is already here. Yeah, sorry for that. So it's from 0 and 1 and 2. So there's no minus 1 here, okay? Yeah, I guess I got yeah. Okay. So let's erase this part. Okay. Okay, that's correct. Okay. Then finally, it's 1 plus 2, 3n minus 1. And if we multiply this out, 1 minus 1, and 1 minus 2 is just a minus. Okay. You double check, this is correct or not. If you let n to be 1, if n to be 1 is 2 times 3 to the 0 minus 1 is 2. So it's 1, 2 minus 1. So it's just 1. So that's the first term. Okay. Then you don't need to check the rest of them. Okay. So you can find, yeah, just be careful when you get it all together. Yeah. Don't mix up with the first term. Yeah, this is a 4. You see, I did not look at this. This is the first term. Okay. Okay. So let's take a look at the next one. The next problem is for what is the next term in the sequence? Okay, and I probably don't want to find the general term here. What is the next term? Okay, what is next term? 3, 10, 21, 36, 55. Okay. Right. Yeah, of course, maybe you can find out what is nth term. Okay. Yeah, find out the next term first. Are you sure 79? William says, yes, 79. Okay, everyone says 78. Good. Okay. All right, so let me begin with 8. Okay, 8 2 minus A1 is going to be 10 minus 3, which is 7. And we're trying to figure out the pattern, right? And that's 3 and A2, 21 minus 10, that's 11. A4 minus A3, that'd be 36 minus 21, and that is going to be 15, right? A5 minus A4, that'd be 55 minus 36. This is 19. So take a look at this patterns from 7 to 11 to 15 to 19. I think each time you add 4. Okay, so this is a asthmatic sequence. So if you add 4, that will be 19 add 4, it's 23, right? So A6 minus A5 is going to be 23. Okay, so therefore A6 is going to be A5 plus 23, and what is it? A5, and that is 55. Okay, so that is going to be 78. Okay, you just need to do a little bit more, then you probably can get the general formula. Okay, okay, so the question is, are we able to describe in this way, right? 11 is described as, I can do several things, okay? And 7, I can describe as 3 plus, yeah. And let me erase this. What happens to this? Okay. 7 can be viewed as 3 plus 4, okay? And the 11 can be viewed as 7 plus 4. That'll be 3 plus 4 times 2, right? And that would be 3 plus 4 times 3. So this is a arithmetic sequence, right? So this 4 and 4 in the match. So the general term will be an minus 1 is going to be 3 plus 4 times n minus 1. So if we add all together, right, adding all them together, you will get the left-hand side is an minus a1. So right-hand side, okay, how many equations here? I think we have n minus 1 equation because we have to count how many 3s there, right? So 3 times n minus 1. Right? And then you have a 4. And then you have a 1 plus 2 plus 3 all the way to n minus 1. Okay. All right, so the first term will be 3 times n minus 1 because you have n equations here. And then 1 plus 2 plus 3 all the way to n minus 1 is actually going to be n minus 1 times n minus 1 plus 1. Okay. So finally, I got okay. Well, I can get a common factor out. It'll be 3 plus 2n. Okay. So what is a1? I think a1 is going to be 3. So a1 is 3. So it's going to be 3 plus n minus 1, 3 plus 2n. Now we have to double check our formula if it's correct or not. Okay. And a1 is good. It's a 3. A2 is going to be 3 plus 1 times 3 plus 2 times 2. So 4, 7, so it's going to be 10. Yeah, it's match. So we stop here. You don't need to don't need to continue. Okay. So this is a formula. Okay. And then using this formula, you can get any terms you want. Okay. Not only just next term. Okay. So what is it? 100th term, right? Plus 100 minus 1, 3 times 2 times 100. So it's a 3 plus 99, 203, right? Then you multiply this out, then you get answers. Okay. All right, so our next problem is specifically we ask you to find the 100th terms. Okay. What is the 100th term? Okay. And you are given the sequence 1, 3, 7, 13, 21, 31, 43. Okay, please work on this. Okay, please work out this problem. Anyone have any answers? Okay. Okay, it seems to me I still needed to figure out how to find the general formula, right? But we needed to know this formula. Okay. This is a formula I have to measure, okay? Okay, so let's take a difference, 3 minus 1, right? I'm going to use A1 and 2 because I'm going to find a general formula. Yeah. Okay. So A2 minus A1 is 3 minus 1, that's 2, no padding yet. A3 minus A2, 7 minus 3, which is 4. It looks better, right? It's right now, okay? A4 minus A3 is going to be 13 minus 7. 13 minus 7 is 6, right? So A5 minus A4 is going to be 21 minus 13. Okay, 31 minus 13 is 8. Okay, and I think we, of course, we have to finish all of them, right? So A5 is going to be 31 minus 21, and that is 10, right? A7 minus A6, make sure all of them correct. 43 minus 31 is 12. So clearly, this is a sequence, an arithmetic sequence, right? Every time you add 2. So I can view it like 0 plus 2 times 1. I use that one, okay? Then here 0 plus 2 times 2. 0 plus 2 times, right? Times 3. Okay, 0 plus 2 times 4. Okay? And here 0 times 2 times 6. So this 6 and that 6 is the same. So an minus 1 is going to be 0 plus 2 times n minus 1. Okay? Then you add all together, you will see lots of terms cancel out on the left-hand side. What is left is an minus a1 equals 2. Here, every term has a factor of 2. So the last term is an minus 1. Okay. Then use a formula. Okay. This is the n minus 1 times n minus 1 plus 1 is n. Cancel it out. And then you get a general formula. Okay, what is A1? I think A1 is begin with the 1, so it's a 1. So this is a formula we have. Okay. Then A to the 100. A is the 100th term. Okay, it's going to be 990, 9,900 or 1. Right? So now you get a general formula. Why do you need to add the 0? Okay, for the convenience, that's a good question actually. I want to begin with, every time I add a 2, so I begin with 2 times 1, okay? So that's why, well, I don't need to say 0, okay? So that's a good question. It's not necessary, just 2 times 1, 2 times 3, 2 times 2 times 2, 2 times 3. Okay. But if the first term is not a 2, the first term is 3, for example, then it will be 1 plus 2 times 1. Okay. So there's a term here, but since it becomes 0, you don't need to copy, write it every time. Okay. Yeah, it's not necessary, I should say, to put a 0 there. All right, our next problem is, that's problem number 7, okay? We are given okay, what is nth term? Okay, we want to find out the general term. Okay. Okay. So A2 minus A1, 8 minus 5, that's a 3. Okay, 3. Okay, no problem. A3 minus A2 is 20 minus 8. Okay, it's 12. Okay. I don't see any padding yet. 47 minus 20, that is 27. Okay. A5 minus A4, 95 minus 47. Okay. So what is that number? Okay. So that is a 4, I think it's 8. Okay. Yeah, 48. A6 minus A5 and 170 minus 95. Okay, so that is going to be 75, right? Yes. Okay, so the general one, I have to figure it out, right? But then let's look at the sequence on this side. I found out that all of them are multiple of 3. So if multiple of 3, I should take it out. 3 times 1, 3 times 4, 3 times 9, 3 times 16, 3 times 25. Okay, then you see all perfect squares. Okay, so that will be 3 times 25 is 5 square, so it's n minus 1 square. Okay, and add them together. So the left hand side is just an minus a1. The right hand side get 1 plus 4 plus 9, the sum of those perfect squares. Okay, A1 is a 5. Okay, A1 is 5. So question is, how can I add the perfect squares together? Okay, there is actually another formula we need for the perfect square. Okay, the formula says that 1 square plus 2 square plus 3 square all the way to k square is going to be k plus 1 and 2k plus 1 divided by 6, not divided by 2. Okay, divided by 6. Okay, if you're not sure this is the correct formula, double check it. When k equals 2, right, there should be 2 times 3, and here's a 2 times 2 plus 1 divided by 6. So this should be equal to, yes, equal to 5. And that's true. Okay. So that's why it's correct, the formula. Yeah. sometimes you're not sure from your memory, and it's not, you have no idea. Okay, double check the, for few values. Okay, so using that, then then you have 6 here. K is n minus 1, so n minus 1 it's n, then 2 n minus 1 plus 1. Okay, that's what you get, and divide by 2. To n minus 1. Okay, so this is the general term, general formula. Okay, and once you get the general formula, I will check whether this is correct. Okay, whether this is correct. Like, look at A3. Okay. Yeah, double check. Okay. A3, 5 plus half. It's a 2, 3. And when n equals 3, it's a 5. Okay. And 15, that should be 20. Is that correct? Yes, that's 20 is answer. So great. This is a formula. It's correct. Okay. All right. But the secondary, you see, we keep taking difference, but the secondary sequence can be obtained by adding the consecutive terms. Okay, so sometimes you don't see any patterns. Sometimes one can try add them together. Okay, you will find out this sequence generated from adding 2 consecutive terms together has some pattern. Okay. Right. And if you take a difference, then there's no pattern. You cannot see the pattern. Okay. So this is example 8. All right, let's take a look at the example. Okay. 1, 5, 7, 17, 31. Okay. I want to find the next term. Okay. So I try, okay, I get this number. I get 5 minus 1 is 4. 7 minus 5 is 2. 17 minus 5 is 10. Right? And 31 minus 17, right? It's going to be, I think it's going 14. But I don't see any pattern here. 4 to 2, 2 to 10, 10 to 14, acting strangely. Okay? The sequence behaves strangely. There's no pattern. I cannot tell. Okay? So this does not work. All right, so let's try add them together. If you add them together, you probably see some pattern. And this sequence, yes, has a good pattern here. Okay, so yeah, okay. So you find some way to generate the next term. That's good, Alex. Okay, 2 times 1 plus 5, 7. 2 times 5 plus 7. Well, it's 17. Yeah, that's pretty genius. Okay, but I'm not going to do that way. So let's try this. Okay, you will get something like that. Okay. Then this is a pattern, right? So the next term will be 1, 2, 3, 4. So the next term, if I put x here, x plus the next term will be, we use, yeah, 31 plus x should be equal to, right, double 48, right? Every time is double, right? 48 times is 96. So x is going to be 96 minus 31. That's a 565. Okay, so the answer is 65. Now, let's take a look at this again. Okay, so yeah, how to get the next term? And what Alex said, it's 2 times the first one plus 5. Okay, then 2 times 5 times 2 plus, right, plus 7. So you just basically just, there are 2 previous terms. The very first term you multiply 2, add the second term. Okay, so this is and here is going to be 7 times 2 or 3 times 7 plus 17. So that could be 31, right? So then the next problem will be like 17 times 2 plus 31. Okay, so that would be what do we got here? That's 17 times 2 plus 31. So that'll be 65. That's also you can get 65. Okay. Yeah, this is an interesting pattern. Okay. Yeah, there's some smart kids can figure it out quickly. But yes, so this is how do we generate the next term. Okay, that's how do we generate the next term. So you can keep it going. So the formula, here's the formula, okay? AN equals is AN minus 2 times 2 plus AN minus 1, okay? Okay. And you are given 1 and A1 equals 1, A2 equals 5. Then you have a formula, then you can generate all the terms, okay? You can generate all the terms. Okay. Yeah, you can get A3 and get A4 and get A5, right? A3 is going to be, right, when n equals 3, so it's A1 times 2 plus A2, right? So it's 1 times 2 plus 5, it's a 7. But it's difficult to get a general formula, honestly, right? So can we get the nth term? Maybe not. Maybe yes. Okay. So I'm not going to discuss this. That's a good question. Can we get the nth term? I want to find the 100th term instead of next term. Okay. All right. Let's take a look at the next problem. The next problem. Yeah, here's the next problem. Okay, given 2, 8, 18, 32, 50. Okay, what is the next term? and what is the nth term. Okay. Right? 72. 72 is correct. Can you, okay. So when you look at all the terms, I find those are even terms. So it's better to just divide by 2. So you get 2a, 2 times 4, 2 times 9, 2 times 16, 2 times 25. So 1, 4, 9, 6, 16, 25. This is a perfect square, right? So the perfect square, so 1, 2, 3, 4, you know, it's 2 square, 1 square, 2 square, 3 square, 4 square, 20, 25 square, 5 square, right? So the nth term is going to be 2 times n squared, right? 2 times n squared. So that's the general term, okay? The general term, okay? So I can get, you know, hundredths term, right? The hundredths 2 times 100 squared, okay? 100 squared. 100 squared is, you know, yeah, you put 4 zeros here, okay? 20,000. So the hundredths term will be 20,000. Okay. So that is how do we get, okay? And yeah, very last one, okay? Given 1, 3, 15, 105, 945, okay? Let's find out the next term. Okay, this is a little bit challenging problem. Okay, we're trying to figure out the pattern. Okay. Okay, we haven't tried the geometric sequence, right? So what we do is 3 divided by 1. You know, I try to see it's not geometric sequence, but what I'm going to get is I will see some pattern. So 15 over 3 is a 5. Okay, 105 over 15 is going to be 7. And the 945 divided by 105, and that is number is getting. So this is a really nice sequence. If you take a difference, I don't see that pattern, okay? So I take a division instead of difference, okay? Then you get the next term, you know, the next term is 6, and that is going to be 11. So 8 to 6 is 11 times 945, and you multiply this out. Right, we solved the problem. Great.